A solar electric system consists of many components, some mechanical, like the attachment hardware, and some electrical, like the PV panels and inverter. The PV, or photovoltaic panels, are the components that produce electricity from sunlight. The solar panels will be attached to a racking system on the roof and connected to form a solar array. The racking components are the first to be assembled on site. Standoffs, mounting clips, and rails are pre-assembled on the ground before they are moved to the roof for installation. The rails form the base to which the solar panels get attached. They give the entire array the necessary rigidity to withstand the elements. The rooftop installation begins with locating the rafters and installing a waterproof attachment system. These standoffs are mounted in no-caulk flashings that have a built-in rubber seal to keep the water out. Standoff mounting components are designed to lift the rails and collectors off the roof surface for two reasons. First, so roof debris and rainwater can easily drain off underneath, and second, to create an airspace between the roof and the panels, allowing the panels to stay cooler through natural ventilation, which improves their overall efficiency. Once the racking hardware is securely attached to the structural members of the roof, the panels get mounted to the rails. Panels can be oriented in portrait or landscape. The portrait orientation is most common. The mounting clips attach the solar panels to the rails. Once the panels have been firmly attached to the racking system, they are electrically grounded for safety, and then connected together to form a solar array using simple quick connect plugs. Typically located near the main electrical panel are the solar system's inverter, AC disconnect, and meter. They are connected to the solar panels on the roof through a run of conduit. Electrical breakers need to be installed for the solar system. These can be installed in any available slots of the main electrical panel. Most solar electric systems are connected to the grid, allowing homeowners to export excess electricity when it is sunny and buy from the utility when it is not. A bidirectional meter capable of measuring in and outflows of electricity gets installed to keep track of net electricity use. A disconnect switch is a safety feature that allows shutoff of the system in case of an emergency or if work needs to be done on the system. The inverter is the brain of the solar electric system. It modulates the system's output to household and grid conditions by adjusting the voltage and converting the current from direct to alternating current. The inverter also keeps track of electricity production and can easily be connected to remote monitoring devices and computers, so the performance of the system can be tracked from a convenient location. Once the installation is complete, the system is ready for testing, startup, and connection to the grid. Connecting to the grid requires the expertise of a licensed electrician. The installer then organizes an electrical inspection and notifies the utility. The solar electric system is now ready to start producing years of clean, renewable energy.